Students, this is part 2, movement of moisture within the solid, part 2. Now I am going to discuss the principles involved in liquid diffusion. Listen, this is wet solid. This is wet solid. The center point is depth of the wet solid. This is called as depth of the wet solid. Depth of the wet solid. This is called as outer surface. Outer surface. Outer surface of the wet solid. The moisture content in the depth of the wet solid is more. The concentration of moisture in the depth of the solid is more. High moisture concentration. High moisture concentration. Moisture content at the surface of the solid is low. Low moisture concentration. Concentration difference with respect to distance. Concentration difference with respect to distance. Concentration difference with respect to distance is called the concentration gradient. Is called the concentration gradient. Just see this. This is the wet solid. It's porous wet solid. Porous wet solid. The center point is called as depth of the solid, where moisture concentration is high. This is the outer surface of the wet solid. Here the moisture concentration is low. Concentration difference with respect to distance is called as concentration gradient. Concentration gradient. In the segment of liquid diffusion or diffusion of moisture occurs due to the existence of concentration gradient. What I am trying to say is, liquid diffusion occurs due to the existence of concentration gradient. Concentration gradient. This concentration gradient is set up during drying from the surface of the wet solid to depth of the wet solid. Are you clear? Diffusion of moisture or liquid diffusion occurs due to the existence of concentration gradient between the depth of the solid and the surface of the solid. At the depth of the solid, the moisture concentration is more. At the surface of the solid, its moisture concentration is less. Concentration difference with respect to distance is called as concentration gradient. This concentration gradient is the main cause for the liquid diffusion. This concentration gradient is set up during drying from the surface to depth of the solid. Clear? This is a base information. Another important point is the moisture diffusivity. The rate of moisture diffusivity decreases rapidly with a decreased moisture content. Rate of moisture diffusion or moisture diffusivity. Moisture diffusivity decreases rapidly. With decreased moisture concentration. Because the concentration of moisture at the surface to depth goes on changes. This is the main reason why falling rate period the rate of drying is decreased. This mechanism is limited or probably limited to certain cases where formation of single phase solid solution. This mechanism, liquid phase diffusion, this mechanism is applicable for certain cases where formation of single phase solid solution. namely soap solution. Soap, another one is glue, another one is gelatin. This mechanism is applicable to the limited cases. Also, some more cases, that means removal of bound moisture. By drying, bound moisture is to be dried, or last portion of the water content removed from clay, last portion of moisture removed from clay, floor, textile, wood and paper and so on. So the concept of liquid diffusion or principles of liquid diffusion is applicable to the limited extent where single phase solid solution is formed with moisture, namely soap solution, glue and gelatin. Also this principle is limited to certain cases where last portion of the moisture or bound moisture is being dried from clay, floor, textile, wood and paper. This is the basic principle involved in moisture content, movement of moisture content within the solid by liquid diffusion. Clear? This is comes under the category of first falling rate period. That means the constant rate period in drying rate curve. This is the constant rate period. This is first falling rate period. This is second falling rate period. In x-axis moisture content. In y-axis flux of drying or rate of drying. Rate of drying or flux of drying. This is the first falling rate period. This is the second falling rate period. The constant rate period ends with an appearance of dry spot. Dry spot is the indication of dry spot. Appearance of dry spot indicates that constant rate period comes to an end. From that moment, falling rate period starts. Dry spot is nothing but a portion of the solid. A portion of the solid. Dry spot means a portion of the solid has direct projection into the gas film. This is the dry spot. Hereafter, the entire area exposed for drying is split up into two cases. One is area of dry spot, another one is area of the wetted patches. This is called area other than dry spot is called as wetted patches. This is called as dry spot. Another one is wetted patches. Dry spot is nothing but a portion of the solid exposed directly or projected directly into the gas film. In this area eventually dried to the equilibrium moisture content. Equilibrium moisture content. Equilibrium moisture content is nothing but in this particular area alone. The vapor pressure of liquid water or moisture present in the bed solid is exactly equal to partial pressure of vapor present in the gas. Equilibrium moisture content is nothing but vapor pressure of liquid water is exactly equal to partial pressure of water vapor. As drying progress, this area of dry spots goes to increase. Subsequently, area of the wetted patches goes to decrease. This period is called as, that means increasing area of dry spot, decreasing area of wetted patches. This tenure, this period is called as unsaturated surface drying. This is called as unsaturated surface drying or evaporation. In liquid diffusion, there will be a formation of dry spots at the end of the concentrate period. Appearance of dry spot is the indication that concentrate period comes to an end. Clear? Comes to an end. From concentrate period, falling rate period begins. At the end of the concentrate period, falling rate period begins. Dry spot is nothing but it is the area projected directly into the liquid film or gas, projected directly into the gas film. This dry spot eventually dries to a equilibrium moisture content of the prevailing gas. Equilibrium moisture content is nothing but vapor pressure of liquid water present in the bed solid is exactly equal to partial pressure of the moisture present in the atmospheric air. Okay, equilibrium moisture content. Hereafter, the important information is drying rate is completely controlled by rate of diffusion. Rate of drying is completely controlled by rate of diffusion. This is the important point in liquid diffusion. Rate of drying. Rate of drying is completely controlled by rate of diffusion. Rate of diffusion. This rate of diffusion is explained satisfactorily with many cases with the average moisture content. Rate of diffusion is explained very satisfactorily in many cases with the average moisture content. This is the necessary information regarding liquid diffusion. By third part is what you call the capillary action. Thank you.